Alright, let's look at the homework 5, problem number 7. Right, so we want to find the complex impedance of Z1 and Z2 in series. Right, so let's do that first. Right, part A, so complex impedance and Z would be just a Z1 plus Z2. Right, so we just need to add them up, so this one's pretty easy. 2 plus 3i plus 1 minus 5i. Alright, so this is going to be 2 plus 1 is 3, and 3i minus 5i would be minus 2i. Right, so this is the complex impedance here. Alright, how about in parallel? Right, so this one's maybe a little bit trickier. So if you want to find, let's say I'm going to go here, Z is going to be, right, so reciprocal of Z1 plus reciprocal of Z2, right, then we take the reciprocal of the whole thing, right? So you're going to get, so reciprocal Z1 would be 1 over 2 plus 3i, right, and plus reciprocal of Z2 is 1 over 1 minus 5i, and then we take the reciprocal. Right, let's find the common denominator. So we're gonna get this. I'm gonna go down here. Alright, so common denominator would be just I'm going to go ahead and multiply. So I'm going to multiply the denominators together. So you're going to get, say, 2 times 1 is 2. And 2 times negative 5i would be negative 10i. And 3i times i would be positive 3i. And then you have 3i times negative 5. Okay, 3 times negative 5 is negative 15. But the I squared would be negative, so it's going to be positive 15. Alright, so that will be the denominator. Alright, then we have to multiply 1 by 1 minus 5i, so 1 minus 5i plus, right, and 2 plus 3i, because I multiply 1 by 2 plus 3i. Right, then we have to take the reciprocal of this guy. Right, so I'm going to go ahead and do the reciprocal and simplify at the same time. So I'm going to put this guy, simplify, put it on top. So it's a 2 plus 15 would be 17. Right, minus, let's say minus 10i and the 3i, so it's going to be 7i. Right, and on top, so 1 plus 1, it would be 3. Right, and negative 5i plus 3i would be negative 2i. Alright, so then we already took care of the reciprocal because I put it upside down. Right, so all you really have to do is maybe multiply top and bottom by the conjugate of the denominator. So it's going to be 3 plus 2i. Alright, so we're going to have to do the same thing so that we don't change the quantity. Alright, so this is going to be equal to, alright, so it's 3 squared would be 9. Alright, then plus minus 2i squared would be 2 squared would be 4. I squared would be negative, so plus 4. Alright, so that'll be 13. And if you multiply this out, 3 times 17 would be, let's see, 3 times 7 is 21. 3 times 1 is 3, so 2 plus 3 is 5, 51. And 17 times 2i would be 34i. And minus, let's see, 7i times 3 is 21i. Alright, then you have 7i times 2i, so negative 7i, so it's going to be positive 14. Right? So what you get is, let's see, combine those two guys as 65 and plus, alright, so it's 34 minus 21, so it's going to be 13i, right, divided by 13, right? So 65 divided by 13 would be 5, and the 13i divided by 13 would be just 1i, right? So this is the complex impedance when these guys in parallel. Alright, that's it. I hope that this was clear.